Hey guys, so our lesson for today is 16.5, and we're going to look at piecewise functions and interpret them in context. So we're going to describe the meanings of the rates of change or slopes, the y-intercept, and any x-intercepts that happen in the graph. So the graph that you see here is the one that we're going to be talking about in our notes. And the graph shows the percent of the charge remaining on a cell phone battery over time. Okay, so the time on the x-axis is counting by twos, and the label is hours, so 2 hours, 4 hours, and so on. And on the y-axis, it is the percent of charge remaining. Okay, so 10% remaining, 20% remaining, 30%, and so on. Okay, so the type of function shown in the graph is linear piecewise. All right, and we're going to talk about what's happening in each section, or what we think could be happening, okay? It doesn't say specifically, but we're going to use our common sense and just talk about what's happening in each section. So in the very first section, A, the amount of power is going down. The amount of charge remaining is going down. In fact, the line is pretty steep, so whatever they're doing on the phone must use a lot of battery. I thought maybe, my idea is that maybe they were streaming a video. That takes a lot of battery, right? Okay. The next part, in part B, it's a completely flat line, okay? A completely flat line means that the phone is not losing any charge at all. In order for a phone not to lose any charge at all, it would have to be off. Even if your phone is on and you're not using it, it's still working in the background and it's still going to lose charge. Section C, we're going down again, it's losing charge again, the person is using it, but the line is not so steep. So maybe they're doing something that doesn't take so much power. Maybe they're playing a game here. And then in section D, the power in the battery is going back up. And what would make the power in the battery go up? Charging it would make it go up. In this section, we're going to talk about the slopes of each section of the graph, slopes or rate of change, and the x-intercepts and the y-intercept. And we're not only going to say what the numbers are, but we're going to talk about them in context. All right, so remember, dig back into the cobwebs of your mind. Slope is rate of change, and it's how steep this line is. We're going to look at section A first. Okay, so section A is right here. All right, and so this part of the line starts at 100 and ends at 50. Okay, and I know these boxes in this direction are counting by twos, so this is 2 and this is 3. So this is 3 hours. And the difference here is 50%. Okay, so when we're calculating slope, it's the change in y over the change in x. So the y value changed by 50, okay? It went down 50%. Over the course of the change in x, which is 3 hours. So overall, the slope of that line is negative 16.6 repeating. We can add the percent sign. Okay, so in section A, the battery lost 16.6 repeating percent per hour. Didn't give myself very much room to write here. Okay, so that's section A. In section B, it is completely flat, which we talked about on the previous screen, but now we're going to talk about it in a mathematical way. All right, if it's flat, that means the y value didn't change. So our change in y would be 0, and our change in x is 5. Well, anything over 5, 0 over anything, I should say, is 0%. So the slope here is 0%, or 0, and this indicates that the charge did not change. The charge did not change. Section C, we're going from here down to here, okay, and that is a change of 25. Okay, so 50 down to about halfway. And 2, 4, 6, 8. Okay, and that's over the course of 8 hours. So it went down 25% over the course of 8 hours. So the change in y, 25, over the change in x, 8. And that comes out 3.125% loss of charge. Just another way of writing it. Per hour. And we should make that negative. Okay? It's going down 25%. In this last section, we're the chart, if the phone is charging, okay, and that's taking place over 4 hours of time, and the charge started out at 25% when we plugged the phone in, and it went all the way up to 100%. So that is a change of 75% that's positive because the phone is charging over the course of 4 hours. So that divides out to be 18.75% per hour is the speed that the phone charges. Next, intercepts. All right, so an x-intercept would mean that at some point our function would come down and touch the x-axis. But the lowest we get is 25%, and then it goes back up again. So in this case, okay, there are no x-intercepts. The phone, and here that would mean that the phone completely died. Okay, the y-intercept is right here. The y-intercept is at 0, 100. And that's telling us that the phone started with a full charge. Okay. All right, then we're going to do just some interpretation questions. Determine which portion or portions of the graph can be described by each statement. So the first statement says the cell phone was not in use. Okay, that was section B, right here in section B where it's flat. The cell phone battery was recharging. We talked about that in a previous screen, and that was in section D, from 16 to 20 hours. The cell phone was in use. Well, it was in use twice, during section A and during section C. The cell phone battery was fully charged. Where was it at 100%? Well, it was 100% to start with, and it was at 100% at the very end of the graph. So the beginning of A and the end of D. The cell phone battery was half charged. Okay, the easy one to spot is here at B, the whole section of B, but I would argue that right here, the cell phone was also 50% charged. So B from hours 3 to 8 and at about 17 hours. That's probably a little more than 17 hours, but thereabouts it was at 50% as well. Alright, lastly we're going to answer a few more interpretive questions on the graph. Number 6 says determine whether each statement is true or false, and if it's false, explain why. The cell phone battery died after 20 hours. Well, that's false because the battery never died. It never got down to 0. Okay? And at 20 hours, it was actually at 100%. So it's false for two reasons. Number one, it never died. And at 20 hours, it is 100%. B, the phone battery lost 25% of its charge during an 8-hour period. Yep, that happened during section C, from 8 to 16, so section C. Okay, the cell phone was used the most between the 16th and 20th hours. Well, the 16th and 20th hours is section D. That's not when it was being used at all. That's when it was charging. D, the cell phone battery was charged twice. Well, it was only charged once, and how do we know that? Because there's only one section of the graph that is increasing. That's the only time it charged. After the first 3 hours, the battery had half the charge it began with. So 3 hours is right about here. And if I follow that up, well, very crookedly, oopsies, yeah, 50%, so that's true. Okay, thanks for watching. See you next time.